sense in their relationship to math and in their relationship to music. I passed out a detailed explanation of what I am trying to accomplish, and in this respect, if I don't have enough time to finish everything today, at least you'll have something to go over and try and present to your own classes if you're interested. This is based on that problem that we first had in section 1.1, which was to take the numbers 1 through 6 and put them in a triangle so that all the triangles are equal, all the sides are equal. Now I noticed something in this triangle. When I first took this problem, I noticed something, okay? I noticed that, excuse my triangle right here. How many triangles do we have? Does anyone know? Anyone?
1.
More than 1?
7.
Close. 1, the outside. 2, 3, 4, 5. So when I attacked this problem, I did the guess and check method. I started by organizing the numbers in sets. I said, okay, there's 1, 2, 3, 4, 5, 6. The counting numbers 6, 5, 4, 3, 2, 1. There's 1, 3, 5 odd numbers. There's even numbers 2, 4, and 6. I took the triangle, okay, and I started with the guess and check method. Okay? I just started 1, 2, 3, and then I said, okay, well maybe 4 will go here. What the heck? 5, 6. I added up the sums on the outside and they were equal. Then I said to myself, okay, let's try another pattern. Okay? Except starting on the inside. 1, 2, 3, excuse me, 3, 4, 5, 6. They also are equal. Okay? 1, 3, 5, 2, 4, 6. If you were to put 1 here, okay? 1, let me just show you. One, 3, 5, 2, 4, 6. The same. They're equal. You can reverse this. You can do this in mirror images. Okay? There are actually 48 different ways you can put this triangle together so that they're equal. The numbers along the outside are equal. I identified something else. I looked at the triangles, the sub-triangles, okay? This triangle, and this triangle. I noticed that those sums in every case are always equal. Then I took this theory of mathematics into this theory of physics. Okay, let's try and see if we can get these triangles so that the numbers, we substitute the numbers now for sense. Okay, the definition of sense is 1/100th of a unit. In music, it's the same thing. It's the distance between 2 half tones. Okay, does anyone play music in here? Should. Okay, so then I decided, okay, let's see what happens if we do this. Okay, I took the numbers 1 through 6 and I decided to try using the original pattern, which was 1 penny for 1 number, 2 pennies for 2 numbers, 3 pennies for 3 numbers, 4, 5, and 6 subsequently. I put this on an equilateral triangle, okay, and I noticed that it balances. I'm not going to disturb this because it took me forever to set this up. But if one was to do this, I've tried this with different patterns, with different associations between the numbers, odd and even, and they always balance. And what's really interesting about this is they balance at the centroid. Okay, this is on an angle. This angle in architecture, I'm not an architect, but this angle could be anything. It could be at any angle. It could also rotate. Because now we're in the physical world defined by north, south, east, and west. Okay? Then I decided, okay, fine, if it'll work for that, let's see what will happen if we have a constant difference. So what I did is I put together a proof, which I have on my worksheet, that this will indeed balance with a constant difference. And to do that, I used, once again, cents. They're 100th division of a dollar. It's multicultural. It's Africa, India, China, Asia. Excuse me, China's part of Asia. America, all over Europe. It's multicultural. So if you have any students that come from different countries, they will also be able to understand this concept. Building this, I decided to try something different. I wanted to see if I could balance as close as possible to an equilateral triangle on a disc, a circle, which has an infinite number of points on a finite line. Okay? What we're trying to do here, once again, is teach children that cents are 100ths of a unit. But not just that. We're also trying to expand their minds so that they'll start thinking about their own theories. Okay? Okay. Now let's see if this will work with nickels. This is the equilateral triangle, as close to as possible, balancing with a constant difference of 1, 2, 3, 4, 5, and 6. And the pattern is clockwise, 1, 2, 3 on the outside, back, counterclockwise 1, to be 4, and then 5 and 6. And there's numerous different patterns that can be used for this array to put the nickels together, or any units together for that matter. And this is here, the circle represents the infinite number of points along the finite length of the circle, in that this could be literally, and I will do it now, rotated in the physical world, and it will balance. There we go. I want to get it bouncing a little better than that. As you can see, it has to be exact. There we go. Bounces. Now, to demonstrate this to students who might be blind, to draw the relationship between math and music, one can take, there's 100 cents in between every half step. You know, okay? There's 100 cents in between here, and here, and here, and here, and here, and here. Okay, now this is what we can do. If we take 100, I don't want to play this too loud, 100, and assign that to C. Label your keys. 200 would be C sharp, 300 would be D, 400 would be E, excuse me, D sharp, 300 would be E, use the same pedal, 500 would be E, and 600 would be F, okay? Now to demonstrate the infinite number of possibilities between this muddy chord, we can take the pitch wheel, which is a standard installation on most keyboards, and literally show blind people it's the same chord. Up there, there. The constant difference can be proved by multiplying 1 by 300 cents, so that's 300. 2 by 300 cents, 600, 900, 1200, 1500, and 1800. And once again, the infinite possibilities are with the wheel. The wheel, just like the wheel that we had over there. Same chord. All right? And I just wanted to say that, you know, there's a game involved for younger children where they can fill out their own natural patterns, and then fill out the 48 different possibilities, and then take it from there, and then fill out the Star of David, because the Star of David is actually made up of equilateral triangles. And then the person the group that wins, that gets done first, gets to choose what they would like to do during recess to burn off some of those calories from the other games. And the question to ask students is, you know, I have in my packet, I came up with all these theories that I have, you know, and a theory is a theory until it's proven or disproven. The question to ask students is, okay, what are your theories? okay? And what would be nice about that is they can come up with their own theories and then put their name on it and hand it in as either a class discussion or hand it in as a homework assignment. Are there any questions?